So our notes for today are just going over the 8 examples of word problems that we have. Because the material or the content is not new. We know how to find missing sides and missing angles. But now we just have a word problem, and we're going to have to figure out, how to solve those. So up at the top of this paper, the front side, we're finding the angle of elevation. So think what does elevation mean? Like if we elevate. Yeah, so we're going to be kind of thinking of in our situations, we're going to be looking up to an object, okay? So that's what it says here. We have a little diagram. When looking up to an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. So as we see here, this person's looking up at a lighthouse. This is actually our first example. So you see how the triangle starts at their line of sight. So you have the horizontal part of the triangle is at their line of sight, but then you see where they're looking up, and that creates the angle of elevation. So in our examples, it says draw and label a diagram, solve for the missing part, round to the nearest tenth. So let's look at number 1. Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So really what we're going to draw is going to look like this because that's the lighthouse example. So we have Casey. Okay, and he's looking up at a lighthouse. Please don't mind my drawing. Sure. Okay, so here's the horizontal. He's looking up at the lighthouse. So here's my triangle. Everybody with me? So Casey sights the top of an 84-foot tall lighthouse. So we know this whole thing is 84 feet. The angle of elevation that he's looking is at 58 degrees. That's the angle right here. He's looking up. And if Casey is 6 feet tall, he's 6 feet tall, how far is he standing from the base of the lighthouse? So which side do you think we're finding? Are we finding the hypotenuse? No, the base of the lighthouse. This is part of the height of the lighthouse. The base would be, the distance between him and the base would be right here. All right, so to set this up, the only thing is since we're talking about the angle of elevation from his sight, we can't say that this side of the triangle is 84 feet. Does anybody have a clue what we're going to do? 84. Yeah, so we got to subtract his height. So 84 minus 6, what would that equal? Okay, so we have a side over here that is 78. So now we are finding x. We're finding that missing side. So look at where your angle is. We have 78 would be the opposite side. And what would x be? The adjacent. So which function are we using? Tangent. So this will be tangent of 58 equals the opposite side, which is 78, over the adjacent, which is x. So are we going to multiply or divide? Divide. So x is going to equal 78 divided by the tan of 58. Y'all are experts now at using your calculator to find trig. So make sure it's in the right. You got it in degrees. So when you solve that, you should get 48.7 feet. Is that what you got? Does anybody have calculator troubles? Need help with? All right, now does every drawing of the situation have to be that elaborate? No. Okay. As you get into, trying to, that's just me as your teacher trying to get you to visualize what we're doing. Okay. So you're fine with just drawing a triangle and labeling it. Number 2, let's read it. The angle of elevation from a kicker's foot on the football field to the top of the goal post bars is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? So here's my little kicker. The angle of elevation from a kicker's foot. So I'm drawing my triangle from his foot. So here it actually wasn't his sight, his vision. We're talking about the angle from his foot where he's kicking. So that angle is 17 degrees. And if he's standing 131 feet from the base of the goalpost, so like this is the post over here. So if he's 131 feet away, we want to know how tall is the goalpost. Does that make sense how we set that up? Okay, so look at it. We have x. Is that hypotenuse, opposite, or adjacent? Opposite. And what is 131? So what trig function do we have? Tan. And you're going to have tangent a lot with these word problems. So tan of 17 equals opposite, which is x, over 131. So will we multiply or divide? We're going to multiply. So we'll have 131 times the tan of 17. Oops. So you're typing that in your calculator, rounding to the nearest tenth. What'd you get? 40.1. Any questions on that? Number 3 and 4 are pretty straightforward, so I want you to work on those. Lean over to a partner, y'all work on it, make sure you're labeling correctly, and then we'll go over them. So I want you to work on 3 and 4. Bless you. Make sure that you compare and share, that y'all are on the same track. I don't think it's cosine. I think it's sine. Try sine and see. And those are a little different, and like with the angle, you're finding the distance from like on the water. It'd be like the adjacent side.
Are we still live?
No. Yeah.
So is this supposed to look like this? The triangle? That's the mom one.
The 9 was here. So it said that the vertical height, I think it said vertical height. So the vertical height was 9 feet, and we want the length of the slide.
Okay.
You're welcome. All right, guys, let's go back and look at this. So let me just draw the slide here. So it told us that the vertical height of the slide was 9. And the angle of elevation was 46 degrees. So we were trying to find the hypotenuse. What trig function did you use? Sine. So sine of 46 equals 9 over x. So here you would have to divide. And did you get like 12.5? Okay, then we have a dog standing. Any questions on that one? A dog standing from the base of a tree. I think it was 5 feet away. And we know that he was looking up at a cat, and that cat had climbed 16 feet of that tree. And we wanted to find the angle of elevation from the dog. So we're trying to find the angle. So that would be opposite over adjacent. So the tangent of angle x equals 16 over 5. So this is where you have to use the inverse. So you have to say tan of -1, 16 over 5. That's how you get x. What'd you get for that one? 72.6 degrees. So these were pretty simple, right? You think? Not too bad. The next ones aren't that bad either. Okay, so let's look at the next ones. The only thing you have to remember for angle of depression, we're looking down, okay? So whatever is going on, like look at this diagram, and number 5 is about the lifeguard. Look at this. We have a lifeguard sitting up on a stand, and they're looking down to a swimmer in the water. So when looking down to an object, the angle of depression is formed by an observer's line of sight and a horizontal line. So we see how they're looking down, and then the angle's formed by a horizontal line. So the angles actually appear at their vision, but this angle of depression is equivalent to the angle of elevation because they're alternate interior angles. That's talking about, you remember with parallel lines, how we have different angles that are equal? We're not getting into that. Just know that angle of depression, we're going to draw a diagram, and your angle is going to be up here, but it is equivalent to your angle of elevation, which is down here, okay? So let's see what, that's the only part that can get a little confusing with angle of depression. So number 5, a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So let's use this example up here to kind of help us draw this out. Are y'all okay if I don't draw like silly pictures? Okay. So we know from up here that here's the lifeguard. They're sitting on a platform. They're looking down. it says that the lifeguard's line of sight is 8 feet from the ground. So the 8 would be right here. The angle of depression is 18 degrees. So remember, the angle of depression is formed by their line of sight in a horizontal line. So this is 18 degrees right here. And we want to know how far away is the swimmer from the lifeguard. So the swimmer is right here at the edge of our right triangle. So we're trying to find this distance. Okay, so looking at your triangle though, remember the angle of elevation would be right here. So that's equal to 18. So you just drop your degree here. Now look at your triangle and let's figure out what it is. So looking at our degrees, we have opposite over adjacent, which is which function? Tan. So tan of 18 equals opposite, which is 8 over x. Will we multiply or divide? So 8 divided by the tan of 18. What will that equal? Say it louder. 24.6. Thank you. So when I said angle of elevation was pretty simple, it is, and so is this, but just sometimes setting them up, making sure you get that angle in the right spot can get a little tricky. Let's look at number 6. We have a pilot in a helicopter who spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So let's draw that out. So I have a pilot in a helicopter. They're up here flying. Okay, that's terrible. You get the idea. The angle of depression, so they're looking. So the angle of depression that's made is 73 degrees right here. So we also know if it's there, then this is congruent, the angle of elevation. So there are our angles in our triangle, okay? It spots a pad on the ground at 1,200 feet. Where do we put that? Yeah, so 1,200. So they like spot that landing pad like right there. So we want to know what's the altitude of the helicopter. What does altitude mean? Height. So you're finding that. Okay, so y'all go ahead, set that up, figure out what the altitude is. And think the numbers should be larger because we're talking about an airplane or a helicopter flying in the air. You know, do they fly at 100 feet?
You can, but it's not preferred.
That's right. So what was your big number?
3,925
feet. All right, very good. Any questions on that one? Number 7 is just a little bit more like drawing. So I want you to skip 7 just for a second. We'll end with that one. I want you to walk through number 8 and solve it all the way through. So you're working on number 8. We'll jump right back to 7. You get like 141.1?
Yep.
Awesome. All right, I wanted to, any questions? I skipped number 7. Sometimes with these work problems, I don't like how some of them are worded. This one's not difficult at all, but I'll show you what I mean. Okay, so let's set this one up. Building A is 480 feet tall. Building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart are the buildings? So we have like building A right here. And building A is 480 feet tall. So then building B is the side of it. I'm just going to do it like this. And we know that is 654. So if we're like on the top of the building from the angle of depression, so you see our triangle created. The angle of depression is 42, so it goes right here. And it says, how far apart are the buildings? Well, for me, in my brain, it makes me think there's space in between the buildings. So I'm trying to figure out that space. Does your brain do that? But here they just want us to find like the distance between building A and building B. So I just don't like how this is worded. But anyway, before we can calculate this, we need to know what this height is. How do we find that? Yeah, so you got to subtract the heights of the buildings. What would that equal?
174.
So now we can find the distance. Is everybody good, though, with angle of depression and how you're looking down, and that's where that angle is, but it's congruent to the angle of elevation? Does everybody understand that? Okay. So this is opposite over adjacent. So the tan of 42 equals 174 over x. So we'll divide. Anybody have that number? Very good. So if you're having issues with calculator, making sure you're getting the right answer, make sure that you're in degree mode. Let me know if you're having issues. That's an easy fix. But other than that, I'm hoping, as long as you can set these up, so when we do our activity in a second, practicing our word problems, you need to have paper out and you need to draw that triangle. I don't want you, some of these are easy to think about visually, but some of you may not want to admit it, but you do better if you just jot that triangle down, put it on paper, and that way you can see it, okay? Definitely have a piece of paper out to do those example problems.